Hey guys, welcome back to my channel. Thank you very much for joining me. In today's lesson, we are going to be discussing scatter plots and correlation. So basically, the concept behind scatter plot is that it's a statistical diagram that you draw on a graph, some say Cartesian plane, and you use dots to represent the data point. And the data points are given as xy values. So a value of x, that's not writing, a value of x and a value for y. While correlation helps us to understand the strength between two quantitative variables. So for scatter plot, the variables can be either associated or correlated. If they are associated, you'll see that a relationship exists between them. Both can be linear, not linear, both can be categorical, or one can be categorical and the other one be quantitative. But for correlation, both variables must be quantitative variables. And so, when drawing your scatter plot, you will realize that there are some things you can identify. For example, the direction. Is it a positive or a negative? So direction helps us to better understand the slope of your graph or function, while the form, if it's linear or non-linear. So we care about the form being linear, as when it's linear you can draw a straight line through those dots or through those points. But if it's non-linear, our correlation coefficient will not be as strong as it should be, but we should always make mention of whatever dots we see. Alright, so for the strength, it can be strong, moderate, or weak. For the strength being strong, you'll realize that, let's use a pen. For the strength being strong, you'll realize that the dots basically form a line, as you can see me at the bottom here doing. Basically form a line. So if you draw a line through these dots, you'll realize that the line can go directly through the dots, making the relationship very strong. If it's moderate, you can see that the line of benefit is drawn and the dots are roughly close to, that doesn't look right. The dots are close to the line, but not directly on the line. For moderate, for weak, the dots are very far from the line. So when it comes on to your correlation, correlation lends between 2 points, -1 and +1. The closer it is to -1 and +1, the stronger the relationship is. My pen is not inking. The stronger the relationship is between the variables. And so, still not writing. Alright. And so we can describe the correlation as being strong, positive, strong, negative, weak, or no correlation. So with correlation comes the correlation conditions, which basically helps us to understand three things. Are the variables quantitative? Are the points straight enough? Can you draw a line through the points? A straight line, or are there any outliers present? So we know that outliers are the data points that are far away from the bulk of your data. And so for your scatter plot, if an outlier is present, you will see that data point way out by itself when being compared to the other data points that would be somewhere down here. So outliers can make your R value or your correlation very strong or very weak, depending on where your R value is. Like up the top here can make it very strong. If it was down the bottom, like a lower outlier, somewhere down here, and the data points are up here, can make your correlation very weak. So always pay attention to outliers because they affect the value of your correlation. Alright? So we're given this point to these points to plot, create a scatter plot and describe the direction, the form, and the length, and comment on any unusual feature.
Good morning, Iron Horse.
That
Miss
may
Bell, can you
exist.
please dial extension 1000? Thank you.
Sorry about that, guys. I am at work. So here we go. I'm going to go to the meet, and I'm going to go to Desmos graphing calculator. I'm going to draw the scatter plot that I just showed you guys just now. So the data points are 2, 2, 4, 4, 5, 5, 7, 7, and 11. So once you go to Desmos graphing, you're going to go to the plus sign at the corner here, and you're going to click on that plus sign. Then you're going to go down to tables so you can get your X values and your Y values. And Desmos is very useful, especially if you have a class that doesn't have your T184 calculators. You can definitely go to Desmos and look at all the critical points that you want. So we're going to go back and see those numbers again. So it's 2, 2, 4, 4, 5, 5, 7, 7, and 11. So I'm going to add my values in X. So it's 2, 2, 4, 4, 5, 5, 7, and 11. So those are my X values. Now I put my Y values under my Y section. So let's go back and see those numbers. So it's 2, 4, 4, 5, 3, 7, 5, 7, 11. 2, 4, 4, 5, 3, 7, 5, 7, 11. Alright, so here we go. So it's 2, 4, 4, 7, 5, 3, 7. I think it's, I don't know. 2, 2, 4, 4, 5, 3, 7, 5, 7, 11. So 5, 3, 7, 5, 7, 11. 5, 3, 7, 5. I don't know. I don't think I'm getting these numbers right, guys. Guys, give me a sec. I am not seeing these numbers right. Let me write it down on a piece of paper so I take notes. So it's 2, 4, 4, 5, 3, 7, 5, 7, 11, 2, 2, 4, 4, 5, 5. Okay, I think I missed out a 7. So that's why my points were looking so weird. Alright. So it's 2, 2, 4, 4, 5, 5, 7, 7, then 11. Okay. So we're almost there. So 11, 7, 5, 7, 3, 5, 4, 4. Okay. So here are our points, guys. Our X values, our Y values. If you look at this side of your graph, you'll see your scatter plot with the dots being drawn. Alright, I'm gonna make it a little bit bigger so you can see what I'm saying. I'm gonna bring, come on, where is the thing? I'm gonna bring this over a bit. So that's what your scatter plot looks like. So there are random dots representing the data values you are given to create your graph. So once you have your scatter plot, you now need to draw your line of best fit. And your line of best fit is basically a line that goes through the middle of your data, where you should have equal amount of dots or data points on either side. And so if you are drawing with your hand, you can start from anywhere once you can find the center. But if you're drawing on a computer, it will just do it for you. So right in the second line here, I'm going to put the equation of the line in the form y equal mx plus b. So I am going to be doing that right now. So I'm going to use y1, and I use y1 because we have x1 and y1 values here. Reason being, if I should go to the third line and put another table, I'm going to show you guys something. It's now x1, no, it's now x2 and y2. If I repeat this step, you'll see x3, y3. So basically, with Desmos, you have to use the x values and the y values that you created in your table before. Alright, so I'm going to go back. I'm going to delete these just not to confuse you guys. I'm going to delete these. And in my second flow, I'm going to put the equation of the line y equal mx plus b. mx1 plus b. Alright, so there we go for our equation of the line in the form y equal mx plus b. And there you see the line of best fit being drawn. So if you look at this line, you realize that we have 1, 2, 3, 4, 5 above and 4 below, which is not bad for your line of best fit. Okay, so if you examine the small section here, I'm going to talk about this aspect here. I'm going to try to increase the space so you can see what I'm talking about. So if we, can I move this? No? Okay. If we examine the small section here that gives us some data points, you realize that you have r squared, which is your determination, tells you how close the points are to the line. You will have your r value, which tells you the strength of your data. You will have your m value, which is your slope, and you will have your b value, which is your y-intercept. And so once you put the equation of the line in the form y1 equal mx1 plus b, you will be given all of these critical points. And these points are very useful as it now helps you to understand everything you want to about the scatter plot that you drew on this side. So I'm going to make this go back a little bit to that region. And we're going to look at this scatter plot right here. So we are asked to describe the direction, the form, and the strength of your scatter plot, and we can definitely do that. My screen is not bringing down. Let me see if I can reduce the size. Okay. So as we mentioned before about the direction, form, and the strength, we need to examine the direction. So similar to your slope, if it's rising, where both are increasing, we say it's positive, and right here you can see that x is increasing and y is also increasing. If you cannot see from your graph, you can basically go to your tables of values and you realize that there's some increase in x and some increase in y. It may not be uniform, meaning that they won't be always increasing the successive number, but there is increase and a pattern can be seen. So right here, we see that the direction is positive as it's trending upwards as it relates to the form. Can you form a straight line through these dots, or do these dots form a straight enough line? We will say yes, the direction is positive, and the form in this case would be linear. If it wasn't linear, you would basically see. Let me see if I can touch the screen, because the screen wasn't allowing me to touch it. Let's see if I can touch it now. Can I? Okay, good. So as I was saying, here you can see the form is positive as a straight line can be drawn through the dots. And if a straight line wasn't obvious, you'll see like some curve. You'll see some curve in your dots, making it non-linear. So if you did not see the dots going up in a straight manner or a straight line form and seeing something like this one would be non-linear. And the other one, which is this one, is now linear. So it's going to be linear for the form. For the direction, we mentioned it was positive. And how do we know it's positive? Because both values are increasing. The next thing we'll talk about is the strength. So for the strength, let's erase that and put it at the bottom and talk together about some here. So for the strength, you basically look to see how close the dots are to the line. Are they very close to make it strong? Are they relatively close to make it moderate? Or are they very much far apart to make it weak? Here, I would say it's moderate because the dots are relatively close to the line. Also, my R value, 0.862 also give you an idea that my answer, the moderate, is perfectly correct. So we say the strength is moderate, not too strong, not too weak. That's around in the middle right there. And we know this because we established that correlation lies between -1 and +1, which makes the center 0. And at this point we say no correlation or closer to 0. On either side we say it's weak. But the closer you get to -1 and +1, the stronger it is, or some would say very strong. Negative. Or we can say very strong positive. So definitely we can use our R value to determine our strength of the variables. We can also be asked to write the equation of the line in the form y equal mx plus b. So in this case, we basically say y is equal to, so where mx plus b it normally is, we need to put the value of m as whatever we're given, which is your slope, which is 0.823x plus whatever the b value is, 1.033. Let's leave it as that. So that's our equation of the line in the form y equal mx plus b. So when you're giving a scatter plot to draw, ensure you can describe the direction, the form, the strength, and tell the correlation coefficient value, and tell what this means. And that's basically how you go about drawing a scatter plot and describing the direction, the form, the strength, oh, I missed one thing, and any other unusual feature. So let's go back to the Desmos a little. I'm going to show you guys what unusual feature they're talking about. So I'm going to erase all of this because we covered this already. So unusual features are normally clusters and outliers. So this icon up here, hope you guys can see this point up here would be considered an outlier. Why? Because it is far away from the bulk, not very far, but it's pretty much far away from the bulk of your data that's down here. So we consider this point to be an outlier. And since an outlier is present, we need to comment on this outlier. So we're going to say outlier present at, and whatever this point is, that looks like 1111. So we're going to say outlier present at the point 1111. And so this will cover the condition that spoke about the outlier condition being present or not. And that's the end of the video as it relates to you drawing your scatter plot and, where is it? Yeah. Drawing your scatter plot and describing the direction, form, strength, and any other unusual feature. So most persons will ask you to sketch this on your paper or send the document to them via email, but I will make my students copy and screenshot and use it. Alright, so here are some scatter plots that you can have an estimate of what the R value would be, which is your correlation coefficient. Sometimes you'll see no pattern, like this one here, you'll see no pattern or trend, neither going upwards nor downwards, basically going right across. So there's nothing going up, nothing going down, it's going right across. So we say this one has zero correlation, where R is equal to 0. I'm going to talk to you guys about one more thing as it relates to your Desmos graphing calculator. So let's delete these numbers and talk to you a little. Okay, so with Desmos graphing, you're also exposed to the scale where you can change the value or change the scale that you're using. So if you want to change your scale on your Desmos graph, you need to come to the, let's decrease this, you need to come to the top section here where you see the toolbar, you click on the toolbar, and here opens up the regions where you can estimate your grid based on the number years you're given. But I always tell my students to make their smallest x value the one you're given in the chart. So like this one, I could say my smallest x value here to be 2, and I could say my largest x value to be 11. So my scale is not too wide, it's just perfect. Grid view, I think I click off grid. And right here, for y, let's take it off. For y, I could put my smallest y value to be 2, and again my largest y value here would be 11. So it's up to you how big you want your scale to be. Some people would start at 0. You can also do that because it doesn't change the value of r. It maybe change the orientation of your graph but not the value of r, or it doesn't change your slope. So you can play around with the scale that's right here. And you realize that if you click off the grid, you're basically going to be seeing some blank spaces representing the points you drew. And if that's what you want on your graph, well, go ahead and use it. But I like to see the grids because the kids sometimes will be asked to find the slope without using the given thing is here. They'll have to find 2 points on the line and find the slope between those 2 points. But sometimes it's easier to just do this section here and get on with it. So thank you very much for watching. I hope this video was useful. If you need further elaboration as it relates to scatterplot and correlation, I'll be happy to help you. So feel free to leave me a comment in the comment section or email me as you guys always do. And I will be happy to help you all. And there we go for that. I'm going to be ending now because I have to prepare for my class that's coming in. So have a good day, guys, and I'll see you on my next video.